All right, so for this part 2, talking about triangles, the properties of the sides and the angles of triangles. Now, the first thing that we're going to look at is there a pattern regarding the angles of the triangles? And of course there is, otherwise we wouldn't be discussing it. And that pattern is known as the triangle sum theorem. Now, I'm just showing you this so that way, you have exposure to it. You do not need to know that word. You don't need to know its triangle sum theorem. You just have to understand what it means. And so we'll talk about here what it means. And so I have 4 different triangles that we're going to use to explore this question. And before we do that, I want to remind you that earlier in the year, if you're in my class regularly, then earlier in the year, a couple of times, we've talked about things where I've said, please don't call PETA on me. That PETA is a group that stands for the People for the Ethical Treatment of Animals. And so for today, for this part of the lesson, I'm going to tell you, please don't call, there's a group that's very similar, and they're known as PET. Please do not call them on me, and those are the People for the Ethical Treatment of Triangles. And so please don't call them. They'll be very upset at this lesson. And so here I have 4 triangles, and we've marked the angles. And so I tried to use different sizes, different shapes of triangles, so a variety of triangles, so we can see, does this really work all the time? And so we're going to start here, and you can take any triangle. And this is a little bit brutal, and so I apologize if you're a very weak, have a weak stomach. You might want to tune out. But I have this triangle here, and what you can do with any triangle is you can just rip his arms off. Told you it's very brutal. And once you've ripped off his arms, you can line up the angles, and then what you see is that it makes a straight line. And as we know from previous grades, a straight line, the measure of a straight line is 180 degrees. So I'm going to set that aside over here. I'm going to take this triangle here, and just like I did with his brother, I'm going to rip his arms off. You take the triangle and you put all the 3 angles together, and sure enough, once again, it makes a straight angle, or 180 degrees. We're going to try this 2 more times. So, of course, we take this triangle, rip off his arms. So violent. And once again, it makes a straight angle, or 180 degrees. And for my last triangle, this triangle is very different. So maybe this one won't work. Maybe it'll only be certain types of triangles. But let's see. Ripped off his arms. And I don't know. Wonder what's going to happen. And sure enough, it does also make a straight angle. So let me orient it here. And so what we can see is that for any triangle, it doesn't matter what the triangle is, whether it's isosceles, whether it's equilateral, scalene, obtuse, right, acute, any triangle, no matter what, if you add up all 3 of the angles together, you do get a sum of 180 degrees. And so that's why they call this the triangle sum theorem. And so the sum, and this is all you have to know, is the sum of all of the angles in any triangle equals 180 degrees. And where this comes in handy is that in some triangles they may tell us 2 of the measures, and we can go ahead and find the other measure. So for example, I might have a triangle that looks like this, and they may tell me that one of them is 45 degrees, and they give me that, which I know is a right angle, so I have a 90 and a 45. So what I can do is I can add 90 plus 45, and then I could subtract that from 180, and I'm going to go ahead and be able to find that measure of the other angle. And so 180 minus the sum of 90 and 45, and then that'll give me my answer. And of course, once I do that, I'll know, or I'll find out that the other angle is 45 degrees. Or maybe they give me one as 30, one as 90, and then I can subtract those, or add the two together, subtract from 180 to find the third one is 60. And so all you really need to know is this right here, that the sum of all of the angles in any triangle is 180 degrees. All right, the next part. Are there any constraints to what the lengths of the sides of a triangle must be? Now, this is known as the triangle inequality theorem. And again, you don't have to know the name. You just need to understand how it works. And so for this exploration, I have some pieces of a skewer that I've cut up. Normally in class, we would do this as a food lab. We would use spaghetti, uncooked spaghetti. But I'm using this because it's a little bit easier to see. And so I've already kind of measured out and pre-cut these. And so this one is 8 inches. I have two that are 5 inches, 4 inches, two that are 3 inches, and then I have one that's 1 inch. And so what I'm wanting to find out is, are there any constraints or any limitations to what the lengths of the sides of a triangle must be? Can I make do I just need to make a triangle 3 sides? It'll make a triangle. So for example, here's 1, here's 2, and then here's 3. Will this make a triangle? A 1, a 3, and an 8. Well, I don't know. Let's see what we can do. Can I make that into a triangle? No, doesn't look like it there. Wonder if I put it like this. Can I make that into a triangle? No, sure enough, I cannot. So what I'm finding out is that there must be some sort of constraints in order to make a triangle. I can't just take any 3 line segments and make a triangle. And so we're going to explore a few different ones in order to see what it is that it seems to be, what the pattern seems to be, and then we'll talk about that. All right, so we're going to look at a few different ones. So a 1, 3, and a 5. Can I make a triangle out of that? A 3, 4, 5, a 3, 5, 8, and a 1, 3, 3. So we're going to just explore some different ones. Obviously, I know that if they get ridiculously different, the 1, 3, and the 8 did not work. Actually, I'll write that over here in the margin, and we'll maybe talk about why that didn't work, other than the obvious reason that they just didn't fit. All right, so a 1, a 3, and a 5. So I have a 1 inch, I have a 3 inch, and I have a 5 inch. Let's see. If I join them here and here, it doesn't quite reach. And then, no, not really. I can kind of make a triangle, but we see that I have this extra piece over here. So that doesn't seem to work. So will it triangle? No, it will not. And so I'm not exactly sure why just yet, but we'll talk about it here in just a moment. What about a 3, a 4, and a 5? Will a 3, 4, 5 make a triangle? So let's see. Take my... And yep, sure enough, looks like that makes a triangle just perfectly. And in fact, this is a special type of triangle. And if I move the camera here, you'll see that that's a right triangle. And it's a very important right triangle, the 3, 4, 5 right triangle. And you'll learn a lot more about that in 8th grade. But in the meantime, what we do need to know is that a 3, 4, 5 does in fact make a triangle. All right, a 3, a 5, and an 8. So a 3, 5, and 8, let's see what that does. Can that make a triangle? Might think, okay, yeah, that seems like that might work, right? A 3, a 5, and an 8. And so, let's see. Oh, almost, but no. Well, it actually doesn't. The 3, the 5, and the 8, for me to get all of the sides to touch, what I find out is they're the same thing. It kind of just makes a line. It's just doubled over onto itself. So a 3, 5, 8 didn't actually make a triangle. Okay, so 3, 5, 8 did not make a triangle. What about a 1, 3, 3? So you might be thinking, okay, well, these other ones didn't. So maybe the 1, 3, 3 won't. So I'm not real sure. Let me grab my 1, a 3, and a 3, and let's see, can we make a triangle out of these 3 pieces? And yep, sure enough, we were able to make a triangle out of the 1, 3, 3. Now, what kind of triangle is this? Well, I know I have 2 sides that are 3s, so this is an isosceles triangle. And I can look and see, well, yep, all 3 angles are acute, so this is an acute isosceles triangle. So it does, in fact, make a triangle. My 1, 3, 5 did not. My 3, 4, 5 did. My 3, 5, 8 did not. My 1, 3, 3 did. And then, of course, my 1, 3, 8 that I started with, the very first exploration, did not work. And so I'm wondering if I can figure out why. And so if I look over here, the sum of the 2 shortest sides. And so my 2 shortest sides is 1 and 3. And so here I have 1 plus 3. And 1 plus 3 is 4. My 2 shortest sides, 3 plus 4 equals 7. Okay? Some of you are seeing the pattern, maybe others are not, and that's okay. 3 plus 5. 3 plus 5 is 8. Okay? And then 1 plus 3 equals 4. All right, and then my original one, which I knew did not work. So that was 1 plus 3 equals 4. And so what we're needing to know, what we need to understand, and again, you don't need to know that it's called the triangle inequality theorem, but what you need to know is that the sum of my 2 shortest sides, and really, technically, it's the sum of any 2 sides, but you can just test it by looking at the 2 shortest sides. The sum of the 2 shortest sides have to be bigger than the other side, than the longest side. And so is 4 greater than 5, meaning the sum of my 2 shortest sides is that greater than 5. And that is not true, so then that is no. Is 7 greater than 5? 7 greater than 5? Yes, that is true. Is 8 greater than 5? No. 8 was equal to 8, right? And so that's why it just made a straight line. So it did not make a triangle. Is 4 greater than 3? And the answer is yes. And so that did make a triangle. Here is 4 greater than 8. The answer is no. It does not make a triangle. So what I need to know, or what you guys need to know for this activity and for this teak, is that if you add up the 2 shortest sides, it has to be bigger than the third side, than that longer side. If the sum of the 2 shorter sides is larger than the third side, it will make a triangle. If it's the same or if it's less, meaning if it's not greater, then it will not make a triangle. So 1 plus 3 is that greater than 5? No, it's actually less than 5, so that one does not make a triangle. 3 plus 4 greater than 5? Yes, so that does make a triangle. 3 plus 5, is that greater than 8? No, it's equal to 8. That does not make a triangle. All right, so no. And then 1 plus 3, is that greater than 3? Yes, it is. And so that's your triangle inequality theorem. And for the last thing that you need to know about triangles are how are the angles and the side lengths of triangles related. All right, and so this is called the opposite side angle theorem. And just like the others, you don't need to know that name. You just need to understand what's happening with the triangles. And so the first thing that I want to show you, I like to think about this as like if it's a light. And so here I have a light, and it kind of, if you look at the way that it shines down, it almost makes like a triangle. And so it looks like a triangle. And I have a large angle here And a large angle here at the top is going to give me a large area down at the bottom, or a large side of the triangle down at the bottom. And what I can see will happen is if I increase that and make the angle larger, then it makes a much larger space at the bottom. Or if I have a larger light, it will light up more of the ground opposite it. And if I have a much smaller light, so smaller light will shine on a much smaller area of ground opposite it. And we see that same thing with the triangle. So here, if I have a very small angle, opposite that small angle, I have a very small side of a triangle. And if I take that and I increase that side, or that angle, so if that angle increases, what happens is that side opposite that angle also increases. And so there's a definite relationship between an angle of a triangle and the side that's opposite. So the bigger the angle, the bigger the side opposite. The smaller the angle, the smaller the side opposite. And that works with every triangle. It works every time. So if I make this angle very, very small, so I have a very tiny angle, I have a very, very small side opposite. If I have a very large angle, I have a very large side that's opposite that angle. I'm also going to put some other videos that are going to explore this concept a little bit further, but I wanted to just give you my thoughts on it and the way that I relate this to a light shining down.